Hello and welcome to my YouTube channel Technocrats. In today's video, we will learn about how to set parameters of MRJE servo drive and also discuss about the calculation required to run a servo motor. So let's get started. For MRJE servo type system, motor consists of encoder of resolution of 131072 pulses per rotation, that is your 16-bit encoder. The most important parameter to set in servo drive amplifier, which will determine the output movement of motor, is electronic gear ratio, or you can say CMX CDV. So let's open the parameter section of servo. So here we have the positional control. You can click here and you can see that electronic gear CMX CDV is available here. So when we click electronic gear ratio, we have two options. One is electronic gear and another is number of command pulses per rotation. So here you can see that we have maximum frequency set at 200k pulses per second. Make sure that this matches your PLC output frequency. The PLC output frequency must be this value or greater than this value, that is 200k pulses. So for FX5U PLC, let's see in the manual, the output form is your transistor type. Okay, the maximum frequency which FX5U PLC can deliver is 200k pulse per second. So we need this is also here available here. So the maximum frequency the PLC can output is 200k, and we have set that in frequency here also. In case you have another PLC whose output can deliver a higher frequency rate, then you can change it from here. It goes to 4M pulses per second, but for now we are using FX5U, so we will use 200k pulses per second. So let's move back. So to attain maximum speed of servo drive, so you can see that at present the value of by default the value is 10,000. So to attain the maximum speed of servo drive, let's set the command pulses to 3600. At present we are getting the maximum speed of 1200 rotation per minute. So we will increase this speed by lowering the number of command pulses per rotation. So let's write 3600. So by going 3600 we can attain a speed of 3333. So we can go up to this speed at the number of command pulses per rotation is 3600. So let's click OK. Now this is the setting part. Now let's move to the programming section of PLC. So in the FX5U we have generally 4 to 5 instructions. Let's start with DPLSY. So I will write M10 DPLSY, and the first register is D0, the another is D, you can say 2, and we can use the access number. So this D0 is your speed in pulses. Now D2 is your positioning address, that is also in pulses. Okay. Now this is your K1 is your access number. So let's suppose we have a scenario where we have to run a motor at 1000 rpm and attain a value of 300 degree. Let's say that at present the motor is at 0 degree. Now we have to move from 0 to 300 degree at a speed of 1000 rpm. So we will calculate this with the help of Excel. So we have used command pulses per rotation as 3600, right? Now for 1 degree rotation, how many pulses we require? That is 3600. Let's say 3600 divided by 360 degree. That is your because 3600 is your pulses per rotation, and the rotation is of 360 degree. So we will get 10 pulses for single degree. Now we have assumed that we have to move it from 0 to 300 degree. So the address, the positioning address will be that 10 into 300. So we will write in D2. So for the D2 the value will be 3000. Okay. Now coming to the RPM part, So we have maximum of 20k, that is 200 into 000. These pulses for maximum RPM. The maximum RPM we have, we can calculate also the maximum RPM, like the pulses in, this is pulses in per second. We will multiply it with 60, that will be per minute. Now let's divide this by command pulses per rotation. So this is our maximum RPM, as we have already seen here also, that the maximum RPM is 4 times 3. So you can also calculate this. Now for 1 RPM, how many pulses do we have? That is the maximum pulse divided by this, okay, and we will get 60 pulses per second if we want to rotate the motor at 1 RPM. So to for 1000 RPM, that will be this value into 1000. So for 1000 RPM, this many pulses per second I have to provide to the servo amplifier. So at the position of this D0, I will write 60,000 pulses per rotation. So sorry, 60,000 pulses per second for D0, and for D2 we have already discussed 3000 is the value for rotation of 0 to 300 degrees. Now if I change the values for positioning and the speed, we can easily use this Excel sheet to convert and program the get the values of positioning address and speed. So that's all in this video. If you like my video, please like, share and subscribe. Thank you.